Hello, class. Okay, I'm back again with some help on 2.4 because again, I know it causes some issues. People don't really sometimes understand like what they're really looking for. And I get that, I get that for sure. Okay, so this is question number 6 on our Webassign for 2.4. So I sent out, I already recorded a video on 2.4 number 5. Okay, and so I'm going to also include that in this announcement. And remember, I put them all on my YouTube playlist for Calc 1 videos, which again, mortifies my children. But please feel free if you want to just kind of check out that playlist and kind of go back and see if you missed anything. You're more than welcome to do that. But again, I will also include these all in the announcement. So you don't have to necessarily do that if you don't want to. Okay, so number 6 says a machinist is required to manufacture a circular metal disc with an area of 2,300 centimeters squared. Already started out great. Put a little accidental mark there, but here we go. Okay, so first things first, the question that they're giving us, right? We kind of have to understand that we're talking about the area of a circle, right? That is what we have to sort of gather from the fact that they're telling us the area and they're talking about a circular metal disc. Great. Okay. So we have like area equals pi r squared, right? And then what they're telling us is that the area is 2,300 centimeters squared. And the first question they say is what radius produces such a disk? So even though, again, they're not talking about it right now, what they're saying is that like f of x, if we think back to like the formal definition of a limit is pi r squared, okay? R is like the independent, well, you know what? I would say f of x. So let me go ahead and say pi times x squared just to kind of keeping it, try to match it up a little bit closely. All right, R, instead of R, I'm just using X just because we use X a lot when we're talking about the formal definition of a limit, right? And so first things first, they're saying what radius would produce this disk of 2,300? So even though it doesn't really feel like it, they're telling us in the formal definition of a limit that like the limit here would be like 2,300. And we're going to find R. So we can do that. We can plug in 2,300 into pi x squared, and then we can solve for x, right? Sort of similar vibes to some of the stuff we've been doing before, but a little different. Okay, so I'm going to say 2,300 divided by pi. There we go. Okay, great. And then I'm going to go ahead and take the square root of that answer. And we get 27.057. I'm just going to write down all of the numbers possible. And then let's kind of go from there because I'll actually, it says round to 4 decimal places. So let me go ahead and write that a bunch out and then we'll kind of go from there. Okay, so it says to round to 4 decimal places. And so I have more than that. So 1, 2, 3, 4. So I think I would put 27. I can't remember. Sometimes I can't read my own handwriting. Yeah, 27.057.6. I think that's 4, right? Yeah. Okay, great. Lovely. All right, then it says, if the machinist is allowed an error tolerance of plus or minus 9 centimeters squared in the area of the disk, how close to the ideal radius in part A must the machinist control the radius? Okay, so even though it doesn't seem like it, they're really asking us to find, they're giving us epsilon because they're saying this is the error tolerance for the area. And the area is, again, like my f of x here, right? And so they're saying epsilon is 9. But again, I know it doesn't really feel like it. But that's just because I know I've done these things before. So what that means we'll do is we'll take 2,300 and we'll add 9. Okay, that'll get us our upper limit, right? So our, like, I'll say Y2 is 23,009, right? And then we'll also subtract that 9 error of stuff. Okay. And so 23,000 or 22,300 take away 9. I know I should feel like a little better. Ooh, that hurt a little bit. Okay, so I think that'd be 2,291, right? Yeah. Okay. All right. So those are my two Y2 and Y1 values. And so what we're going to do is we're going to do the same thing we just did, but instead of using 23,000, we're going to be using 2,000. I keep saying 23,000. I'm sorry, 2,300. We're going to use 2,309 and we're going to use 2,291. Okay, because that's again like the error we have to work with. All right, so if you want to, we'll say like 2309 equals pi x squared, right? 2291 equals pi x squared, and we'll solve each of these, okay? Just like we just did, which again, I know might seem like just, we're doing the same thing again. So we'll do 2309 divided by pi. I have to use my mouse for these, so I always gets a little rough. Okay, there we go. And I'm gonna go take the square root of that. We could probably have done that all in one step with some parentheses, but I don't know, I was just being kind of lazy. Okay, so that means that like to match up with 2,309, which would be like my upper limit there, right? Would say like X would have to be 27.1105. And then we do the same thing again, but for 2,291. I think I said the number correct that time, so I'll take that as a win. Okay, we'll do the same thing, divide by pi, and then take the square root. Okay, and so there are a lot of decimals in here. Oops, did I go off? Oh yeah, I did. I was like, whoa, what happened there? I'm getting too confident. And he's saying the number correctly. All right, 2,291 divided by pi is what we have to do. Sorry, and then we'll take the square root of that. I was like, whoa, that number is far away. Also, I'm sorry, my husband's watching the Ravens game, so if you hear any like random exclamations, please ignore that. Okay, all right, so we'll say 27.0046. Yeah, okay, to 4 decimal places. Lovely. All right, so let's go back here. So then we'll go ahead and enter in these values. I'll probably put the smaller one first. So I'll put 27.0046, great, and then I'll put 27.1105. But then from here, they're like, okay, so what actually are we doing here if we talk about this in terms of the formal definition? Okay, so in talking about in terms of the formal definition, we already sort of talked about this when I first started talking, is like, okay, X in this regard is like the independent variable, what we're inputting, which is the radius. Okay, f of X would be the area. Then it says, what is A? So it's talking about what value are we approaching? Let me see, let me clear this out. In the x-axis, right? That's like, okay, we're approaching here ideally this radius of 27.0576. That is the like ideal radius that I'm looking for, right? So I'll go ahead and say target radius, because that is like that's the ideal goal of getting us the exact Y value of 2,300. But we also know there's a little bit of wiggle room. Okay, so we're saying we're approaching the target radius. That's why I'm going to put target radius. And then what is L? So L is again like the target area. This is what we're shooting to get, which is 2,300. So I'm going to say target area. And then it says what value of epsilon is given. We'll go ahead and say that was 9. Okay, remember that was like how much error. It's same idea. Error, epsilon, it's all good. And then what is the corresponding value of delta? So we already actually did all the hard work for this because we found like the two corresponding possible radiuses that match up. So the last thing we have to do is remember all that delta is the absolute value of X minus A always has to be less than delta. Oops, messed up my delta again every time with my online pen. It doesn't go well. Okay, so let's go ahead and say delta. So we already have like, let's go ahead and call this like X2 and X1, and then we'll find the difference between like X2 and again, the target radius, which was 27.0576, and also find the distance between our other X value, which was 27.0046. Again, the distance between that and our target radius. Does that hopefully make sense? So for this one, it's just like a different way of like viewing this limit definition, but it's all good. So what I'm going to go ahead and say is I'll say 27.0576 take away 27.0046. Right. So do you guys know, like maybe see what I'm saying, where like we're not really doing anything in these problems, like we're not actually finding any limits. We're just like talking about like, okay, if I moved up this direction, my epsilon's this, so my delta would be this. Okay, if I move in this direction, if I go, my epsilon's this, my delta would be this. Just like over and over and over again. That's all it is. Okay, I'm gonna do the other one now, which again I know was a little bit higher, so I'll say 27 0.1105, take away 27.0576. Okay, and so this delta was 0.0529. Oof, they're both so close. Which one would technically be bigger? Let's see. They're very, very close. Let me go ahead. So technically, delta one, if you like kind of like sometimes do this in my stats class, there's a lot of rounding there. We have like would be 0.0530, right? So essentially you would end in like 30, I don't even know what that would be, one tenth, 100,000, 10 to 30, 10,000th, right? And then versus 0.0529 would be like 29, 10,000. So technically the winner would be 0.05 29. However, if we only wanted to round to 3 decimal places, then they both would be equivalent. Okay. So I hope that makes sense. Again, I know this is like I'll be sending out about 3 videos with this situation. Oh yeah, I'm gonna go ahead and just pop this key up here for you just so you can kind of see. I have 3 videos. The first one, again, was a problem that matched the checkpoint. This problem is one that is trying to like relate it to something in the application type world, which I mean does make sense. It is true, but it just I know can be complicated. And then the other one that I'm sending out again is a complicated one that we have to use our graphing calculator because we're not able. Like here again, the equation was pi. Let's say pi times x squared equals blah blah blah. So we were able to divide by pi and take the square root. Sometimes it's ugly. We can't do that. There is like no way to solve for this equation. We just can't do it. So we have to use a technology. So I also will have one of those. So I hope between all of these they help you a bit with 2.4. And then you can keep me posted. Keep me posted. All right. Thank you, class.